Welcome to Tech Diet. Let's dive into our today's problem. Determine if a cell is reachable at a given time. It says we are given four integer start x, start y, finish x, and these are non-negative integer. Also, t is given to you. It's an infinite 2D grid. You need to start at the starting cell, and you must move to any of its adjacent neighbors. So we are allowed to move in the eight directions: left, right, up, down, and all the four diagonals. So we need to return true if we can reach from the starting point to the finish point in exactly t seconds. So it's not less than, not more than, in exactly t seconds we need to reach that point. So our first test case we are at 2 comma 4, we want to reach at 7 comma 7. So this is one path that is shown. So we can move one distance, it's consume 1 second. 1, 2, 3, 4, 5, then 6. So in exactly 6 seconds we are at from start to finish. Let's look at the second test case. So we are at 3 comma 1, we want to reach 7 comma 3. So we took 1, 2, 3, 4 seconds to reach the finish line. We can't reach it in less than 4 seconds to the finish line, but our given time allowed is 3, so it's definitely a false. So what's happening here is the y coordinate is actually two distance apart, the x coordinate is actually four distance apart. So we need to make a minimum of 4 position change so that we can reach our finish x. Similarly here we are at 2, we want to reach at 7, so we need a minimum of 5 position jump so that we can reach the finish line. And here we have sy and fy, so here the difference is 3. So since diagonals are allowed, so I can consume this 3 within the steps when I'm moving towards fx. So what I mean by that is, so I start from here, then I'll move to this index. In one position I covered the y and as well as x, then I again covered y and x, again y and x, then I just move x forward. So this is the minimum time units that I need to go from start to finish. That is 1, 2, 3, 4, 5. This 5 is nothing but the difference between how far your x and y coordinates are and what is the maximum out of them. So that you need to ensure to reach the finish point, you must at least cover that distance. So that is the minimum time that you need to go. We'll use that approach. We'll try to find out what is my x differences. So since the elements could be anywhere, so let's have a absolute difference between the finish x and the start x. Similarly have the absolute difference between the start y and the finish y. Then we need to find the minimum time I need at least to reach the finish index. So that will be like what is the maximum of y difference, so that will be at least those many steps I need to take to reach that spot. Now I can say if my minimum time is less than and equal to allowed time, since I can move backward and forward, so now when I do this 1 2 3 4 5, in 5 steps I reach the finish line, but I have to reach to 7 line, so I can reach there and I can do one more down so that I can reach the finish line again. So in that sense you can always land into the same index if it's more than the minimum time. So let's run our understanding there. So we'll try to run it over the given test cases. Let's run it when the index is 5, the allowed time limit is 5. So we do have true there. When the allowed limit is less than 5, it will be false because we can't reach there. When the allowed limit is more than 5, bit even odd, it doesn't matter, it's always true. So now let's look at another test case. When I am at the same starting, my finish points are same and my time allowed is 0. So I'm since starting and ending point are same, we don't need to move, so we are at the same index, so the time required there is 0, which should be true. So now let's say if I make it 2, so we're standing and there and the finish is also this point, so you can go upward, come back in 2 seconds, you will again fall back to the same position where you were at, so this should also be true. Okay, so now let's say if I give 3, can I go back to the same index in three positions? I can. How? So let's say we start from here. We'll move left, we'll move down, then we'll move diagonally. So it'll consume 1, 2, 3 seconds. So there. Now let's add a 1 here. So I'm starting and finish point are same. Can I move back to the same index in just 1 second? I can't do that in single move. You can either move to left, right, down, or any of the eight diagonal, any of the eight positions, the eight neighbors. So that means it's a special case where my starting x is equal to finish x and my starting y is equal to the finish y. Then I need to check uh, the t should not be equal to 1. So it should be, it can be 0, it should not be 1. In 1 second there's no way I can reach to the my destination. So let's try to hit submit. It's accepted. Thank you.